Hello dear friends, welcome to my channel. Today's discussions is ISI mathematics linear algebra. Given that the matrix 0x1 0 1 0 0 1 y0 has three linearly independent, three linearly independent eigenvectors. What must be the value of x plus y? So friends, three linearly independent means linearly independent means diagonalizable. Matrix is diagonalizable. Diagonalizable. Okay. So what must be the value of x plus y? So friends, we need to find out the eigen values. So eigenvalues are mod of a minus lambda I equals to 0. So minus lambda 0 1 x 1 minus lambda y 1 0 minus lambda. So friends, now how can I find these values? So in here minus lambda, okay. So 0 into 0, so it is again it is minus lambda into 1 minus lambda, okay. Now 0 opposite side is 0, so another is plus 1 minus minus plus lambda minus 1. So lambda square into 1 minus lambda minus 1 minus lambda. So we get the value is lambda square minus 1 into 1 minus lambda. This is the value. So I get the value is lambda minus 1 whole square into 1 plus lambda. So friends, so I hope it is clear that how many we get eigenvalues. Eigenvalue is 1, 1, okay, 1, 1 and minus 1. Three eigenvalues I got. Now the question is that it is minimal. Now the according to question it is diagonalizable. When it is diagonalizable, then minimal polynomial a, suppose it is let it is take a, minimal polynomial is equal to linear factor, means it is lambda minus 1 into lambda plus 1. Simple, okay. Minimal a lambda, so lambda plus 1 mean, so I can write a minus I into a plus I. Minimal polynomial is the annihilating polynomial, so I can write this is the smallest annihilating polynomial, so I can write this way. So now whatever I get, when I get minus 1 0 1 x 0 y 1 0 minus 1 1 0 1 and 1 0 1. So multiplying both this, that what I get if I multiply this way, so 1 into minus 1 x into 0, so I get 1 0, okay, and x into 1 I get x plus y, and similarly previously multiplication 0, and this way I don't need to do so many, I get got is equal to 0. So my answer is x plus y is equal to 0. This is my answer. Answer is 0 is my answer. Now next is a theory. Let V be a finite dimensional vector P such that V tends to V be a non-linear transformation such that P square is equal to P. Which of the following statement is true in general? Okay, so in general, which is not true? Okay, not true. First is the car P such that car I minus P is equal to 0. This is true. Okay, this portion is true, this portion is true, and this portion is true. It is not true, so it is false. This is my actually answer. So how can I find out? Because if you follow the books, linear algebra books, then you can easily solve this problem. So let x belongs to car P intersection car I minus P. So x belongs to both and x belongs to car I minus P. So I can write that Px equals to 0 and I minus Px equals to 0. Okay, so I minus Px equals to 0. So Px is equal to 0, so x is equal to 0. So my this answer is correct. This is true. Now I minus P whole square and I minus P. Okay, you can also solve this problem converse way. Okay, no converse. Okay, conversely you can solve. So I minus P whole square. Now I can write I minus P whole square into x. Okay, so it is I minus P into I minus P as I into minus P and minus P. So it is I minus P plus P into x because P. So cut this. So we get I minus P into x. So this is my proof. Okay, I have done this proof. Now I can show also another way that car P. Okay, so I can show another way. Okay, another factor is suppose P equals to, this is correct. Now second proof, second option, second explanation, second question is I minus P into y equals to x. Okay, no problem. This is the I minus P v. Okay, I minus P y equals to x. So okay, alternatively conversely proof. Okay, this is this proof also as converse. Y minus Py equals to x and Py means y multiply P in both sides, Py minus P square y is equal to Px and Py minus Py is equal to 0, so Px. So friends, x belongs to car P. Okay, so I minus Py x belongs to car P. So car P is equal to I minus P. This is also true. This is also true. Now dimension of curve P is equal to dimension of PV. Now dimension of curve PV means dimension I can let P is equal to 1 0 0 triple 0 triple 3 0 0 0 0. So dimension of curve P, dimension of curve P is equal to 2 because as u0 you see 2, and dimension of range P I have to find out which is not true. So my option D is correct. And now let's check total problem. So I just minimize this, then you can get this is my total result. Okay, so I think that I can clear my total concept. Thanks for